Hey you guys, so this right here is notes number 3. Go ahead and write down your FLT. I hope you guys are doing well. And play whenever you're ready, okay? Here we go. Given a polynomial, I will be able to factor them by knowing how and when to use a variety of methods, such as GCF, DOTS, and factoring trinomials. Okay, so by the end of this lesson, you guys, you want to get really good at not just knowing how to use GCF, dots, and factoring trinomials, but also the when. How and the when, okay? So make sure, and I'll check in with you guys at the very end. Think about that, have that in the back of your mind, and I'm going to keep repeating those ideas. How do you know how to use it, how to factor, and when to use it, okay? Because there's no point in knowing how to use it if you don't know when to use it. Okay, so first off, why is it so important to know how to factor? Okay? When you guys factor, you're making things look simple. Or simpler, okay? And when you can break things down to the point where they look simple, it's easier to solve a problem. Think about everyday issues that you guys have, right? When you have a complicated problem, whether it's personal or school related, what you try to do is you try to break it down to a point where anyone can try to understand it, right? If you break it down into maybe smaller pieces, it'll be easier to handle personally. And that's the whole kind of parallel with math, okay? Factoring will help us make things look a little bit easier. But really, the whole purpose of math, you guys, for any math that you guys learn, it's to understand patterns and to predict behavior. Okay? If you can understand how patterns work, you can predict what's going to happen in the future. Okay? That's why we have so many data analysis or analysts who can predict what may happen in the near future, or if the stock market is going to drop, when to buy, when to sell. Math goes into a variety of fields, which is pretty much the purpose of understanding how trends work and why you want to break things down. And it starts with something super fundamental like factoring. Okay, so if you guys are asking, like, why am I doing this? You know, there's really a bigger picture that you guys haven't seen yet, but you will. Okay, so 3 things that you guys want to do. We first want to learn how to factor by GCF, dots, and trinomials. Okay, so we'll go one step at a time. Here we go. So GCF, you guys have seen for many years, it's called the greatest common factor. Okay, so let's break this down real quick, okay? Because when you're in my class or when you move on to a different class, I want to make sure that you guys are using your words accurately, okay? Especially when you guys are trying to articulate yourselves. First off, a factor is a number that you multiply with. So for instance, the factors of 8 are 2 and 4. So 2 is a factor and 4 is a factor because 2 times 4 gives you 8. Okay, so when you're thinking of a factor, you're thinking of a number that multiplies, okay? Common means that you want to share that same factor with someone else. And greatest just means, well, what's the largest number or the largest factor that you guys have in common with, all right? So, here we go. GCF. So first the how, okay? Here's example 1. They'll just say factor. They won't tell you how, okay? But we're just going to focus on GCF now. So let's say that we had x to the third plus 5x squared, okay? Even though I'm not asking you guys, pause and play. Can you classify that polynomial? Play whenever you're ready, okay? This right here is a cubic binomial. Cubic because of the 3 degree, and binomial because there are 2 terms, okay? All right, so what you do is you want to factor. You want to take something out. So what you do is you set up a parentheses, all right? And out here is what you're going to factor out. Over here, I have x cubed, meaning I have x times x times x. Those are all factors because they're multiplying, okay? You have a 5 and 2 x's because 5x squared, right? What do we have in common? Obviously, we have x's in common. Now, what's the greatest that we have in common? What's the most that we have in common? So if you take a look, we both have x's, but we both have exactly 2 x's in common. We can't say that we both have 3 x's in common because I have 3, but you don't have 3. Okay? But we both definitely have 2 at the most. So what I'm going to do is I'm going to take out 2 x's, so x squared. Now, if I take out x squared, how much will I have left? Well, if I take out 2 of my x's, I'm only going to have 1 x left. So I'm just going to put x right there. You could put x to the first power if you wanted to, but nobody does that. Down here, we have a plus sign. Now, I took 2 x's away from you. What do you have left? You have that little 5 left, so I'm going to put x plus 5. So right there is the factored form. Okay, you factored out the greatest common factor. We'll do a bunch of these to make sure you guys are comfortable, okay? And if you've seen this last year, great. If not, don't sweat it. You guys will learn it today, okay? Let's do another one. 4x to the 6th power minus 3x to the 5th power, okay? Go ahead and try this one here. Pause and play whenever you're ready. So over here, I have 4x to the 6th, so I have 4, and then I have 6 x's. You have a 3 and 5 of those x's. And, you know, I write this over here so you guys can see it. Should you write this out every single time? Definitely not. It's just to give you a visual, okay? So we're going to factor out what we have in common. What do we have in common? We have x's in common, but how many? We have 5 in common. So what am I going to take out? X to the 5th, okay? So what's left? If I had 4x to the 6th and I took out 5 x's, I'm going to have that 4 left with just 1 extra x left over. If you had 3x to the 5th and I took out 5 of your x's, you're just going to be left with just that minus 3. And that's it. Okay, let's do one more. Try this on your own here. 2x to the 4th plus 5x to the 9th. Pause and play whenever you're ready. Okay, so here you have actually, I'm not going to draw it out. You guys have 4 x's in common, so I'm going to factor out x to the 4th. If I take out x to the 4th, I'm going to be left with just the 2. And you're going to be left with the 5 in the front, but 5 x's left over because I took out 4 out of your 9. If you got that, great. If you didn't get that, text me, ask me so I know, okay? Here's part D. Now, what if you guys had x cubed plus 3x squared plus 5x? Okay? How is this different, right? Well, this is different because now we have a trinomial. We have more terms. So if you have more people in your group, you have to be fair to everybody, right? So we just have to consider all 3 people now. So let's say I'm the first term. I have x to the 3rd power, so I have 3 x's. Okay? You have a 3 in the front with 2 x's, and your friend has the 5 with 1 x in the front. What do we all have in common? What's our greatest common factor? Pause and play whenever you're ready. You only have one x in common altogether. So you think about what's left. So if I had x cubed and I took out one x, I'm going to have x squared left over. And then you, if I take out one x, you're just going to be left with 3 and that one extra x that you have. And if your friend had a 5 and an x and I took their x away, you would only have a 5 left. Okay, that's the how, okay? The when is, when do you know how to use GCF? You should always check for GCF. No matter how many terms you guys have, GCF can always happen, okay? So here's example 2. This is where it gets a little different. Same idea, but you have to consider other things here. So let's say you had 4x cubed plus 6x squared. Okay? So the thing is, pause and play here. Tell me if we have any x's in common. Okay? So in this case, we do. Exactly how many x's do we have in common? We both have at least x squares in common. Okay? But if you take a look at the 4 and the 6, 4 and the 6 can be broken into factors, meaning that there is something that we could possibly have in common too. Is there something that goes into 4 that also goes into 6? Okay? And I'll write it out here, but eventually you shouldn't have to write it out. Some of you that have a tough time with multiplication, it's okay. But the only way you're going to get better at this is if you keep practicing, okay? So if you think of 4, that's 2 times 2. And 6 is really just 2 times 3. So notice how we have at least 1, 2 in common. So I'm going to take out a 2 here. All right? So here's my question to you guys. 2 times what will give me 4? 2. 2 times what will give me 6? 3. All right? And then we talk about our x's here. So remember, you guys had 3 and I took out 2, so I'm only going to have 1 left over. You had 2 and I took out 2, so you're not going to have any left. So it'll just be a 2x plus 3 and that's it. A little bit weird at first, but let's keep doing some more to get you guys used to it, okay? Go ahead and let's try this one here. Let's do 5x to the 7th plus 30x to the 4th power. Okay? You could do this one on your own. Go ahead and pause and play whenever you're ready. Okay, so right here, if I'm just looking at my coefficients, out of 5 and 30, I know the largest number that could divide both of those in is 5, because 5 goes into 5, and also 5 goes into 30, right? 5 times 1 will give me my 5, and 5 times 6 will give me my 30. Okay? I wouldn't draw all those arrows. It's really just to help you guys out. Okay, so now let's handle our x's. I have 7 x's. You have 4 x's. How many do we have in common? We have 4 x's in common. So if I had 7 and I took out 4, I'm going to have 3 left. And if you had 4 and you took out 4, then you're not going to have any left. So we'll just bring down that plus sign. And that's it. Okay, let's do one more here for you guys to check. Let's do 3x to the, let's do 3m to the 10th power plus 12m to the 2nd power. Go ahead and do that there. and then I'll reveal the answer in a second. Okay, so pause and play whenever you're ready. Okay, so here, if we're just looking at 3 and 12, I could take out a 3. 3 times 1 will give me 3. And 3 times 4 will give me 12. Out of the M's, I have 10, you have 2, so we have 2 in common. So if I take out 2 from my 10, I'm only going to have 8 left. And if you had 2 and I took out 2, you're not going to be left with anything, so we'll just leave that blank. You should have gotten that. Okay, hopefully you're catching this. If that's not enough examples for you, text me. I'll give you some more to try, okay? Now, here's the last one. Example 3. Now, I only put this in here because people tend to flip out when this happens. Let's say you had 8x plus 4. All right? Pause and play, all right? Try it on your own. Notice there are no x's in common. I have 1x, but you have nothing. So I'm not going to take anything out. So all I have to look at are the numbers. Is there a factor in common with 8 and 4? Okay, 2 ways that you could have done this. And let me do a split screen here, okay? I want you to think about what goes on the outside, okay? The more correct answer would have been 4. If you said 2, you're not wrong, but let me talk about that later, okay? If you take out a 4, 4 times 2 will give you the 8, okay? And 4 times 1 will give you the 4. Okay, we didn't take out any x's, so I'm just going to bring down that 1x right there, and don't forget my plus sign. If you took out a 2, you're not wrong, you're just not completely right. So look, 2 times what will give you 8? That's going to be 4, and then I have an x there, right? 2 times what will give me the 4 here? 2. So what you did was you factored out something in common, but you did not take out the greatest common factor. So let's say if you're not sure, what you need to do is you need to check the inside. Is there something else that I can factor out of 4 and 2? Right? There is something. There's a factor that goes into 4 and 2, and that's an additional 2. So right now you guys have this, but these two have another 2 in common, so I can take that out. And 2 times 2 will get me this 4. And 2 times 1 will get me this 2. No x's were taken out, so I'll bring that down. So here, if you clean that up, 2 times 2 on the outside will just give you a 4. And you do end up with the same answer that I got on the left-hand side there. Obviously, that's a lot more work, but if you're not super strong with multiplication, it doesn't mean that you can't do it. You just got to do a little bit more, all right? So when you guys are doing these problems, make sure that you're not just factoring out a common factor, but you're factoring out the greatest common factor here, okay? All right, second thing. So you guys know how and when to factor by GCF, okay? Remember, the when is, you can always check for GCF. The next one here is DOTS. That stands for difference of 2 squares. In some books, it's difference of perfect squares, but DOTS sounds a lot cooler than DOPS, right? Difference of 2 squares. Difference in math is a minus sign. 2 means that you're going to have 2 terms here, and they're both going to be squared. So you're going to have something squared minus something squared. Okay? This one is a lot easier than GCF, so here we go. Here's example, what are we on? Example 4. Okay, so factor, we'll write it out one more time. Let's say you guys had x squared minus 10 squared. Okay, so we check, is this a difference? Yes, it is. There's a minus sign. Do we have two squares here? I have a square here and I have a square here. So I know I'm good. So here's how you guys factor it. You set up two binomials, two parentheses. You take your two bases, which I'll highlight it in green. Those two bases, you're going to use those and you're going to write it here, x10, x10. One factor will have a plus sign, one factor will have a minus sign. You could flip those if you guys want to. It doesn't matter because when you multiply, it doesn't matter the order. As long as one is plus and one is minus, you're all set. And that's it. You factored it. Let's try another one. Here's part B. X squared minus 4 squared. Okay, pause and play whenever you're ready. You should have gotten x plus 4, x minus 4. You can even write x minus 4, x plus 4. It doesn't matter. Cool. Here's part C. A little bit different. X squared minus 25. Okay, so look, notice how we have the difference, but we don't have the two perfect squares, visibly at least. So here's what you got to do. You got to write it until it's in the perfect setup. I already have a square here. I have my minus sign. Can I make 25 look like a perfect square? Well, what squared gives me 25? 5 squared. So now do I have a difference of two squares? I have a difference of two squares. So I know I can factor it. Pause and play. It's going to be x plus 5, x minus 5. And that's it. All right. Try this one on your own. X squared minus 36. Pause and play whenever you're ready. That's going to come out to x minus 6, x plus 6. I wrote the minus there just to show you guys that it really doesn't matter which way you guys write it, okay? X squared minus 6 squared. That'll give you your difference of two squares, dots, okay? Let's go to the more complicated ones. Here's part E. 9x squared minus 49. Okay? So right now, we have a difference, but we don't really have perfect squares. And also, some of you may note, well, there's a number in the front here too, which makes it weird. So here's what you guys do. You stencil it, okay? I want to make this look like dots, right? So let's start with the easier one. What square gives you 49? 7. 7 squared, 7 times 7 is 49. What squared gives you x squared? Kind of a weird question, but it's just x. What squared gives you 9? What number times itself gives you 9? That's actually 3. So you have to fix the first one in this case. All right? So now that you have it, what does it look like? Pause and play whenever you're ready. It'll be 3x plus 7, 3x minus 7. Notice how whatever appears first, I always write down first. Okay? Order in that case always matters, okay? Let's try one more. Let's do 25m squared minus 64. Pause and play whenever you're ready. So currently, it doesn't look like a difference of two squares yet, so I'll stencil it in. Okay, 64 is definitely 8 squared. M squared will give me m squared. What squared will give me 25? 5m squared. Okay. From there, I'll get 5m plus 8, 5m minus 8, and then you're done. All right, here's one more. Super challenging, here we go. 100m squared minus 49x squared. Pause. It's okay if you don't get this one, but really just think about it. You guys have enough, you know enough to navigate through this problem. So pause and play whenever you're ready. Currently, this does not look like two perfect squares, so I'm just going to stencil it out. I know that x squared gives me x squared. 7 squared gives me 49. So if I use that same logic on the left here, 10 squared will give me 100 and m squared will give me m squared. So this is going to be 10m plus 7x, 10m minus 7x. That's as tough as it gets. Okay? Dots you should have a very easy time with practice, okay?